The Moon and the Secret of Water, Humanity's Next Great Leap. For thousands of years, humans have gazed at the moon with wonder. Hanging like a silver lantern in the night sky, it has inspired poetry, myth, and curiosity across every civilization on Earth. But despite its constant presence and influence over our tides, calendars, and imaginations, the moon has long been considered lifeless, a dry, airless sphere, forever silent in the vastness of space. This perception began to shift only recently, in the grand scale of human knowledge. Though the moon is Earth's closest celestial neighbor, at just 384,000 kilometers away, it has kept its secrets well. For most of history, we believed it held no water at all, a belief rooted in centuries of observation and the first samples brought back by the Apollo missions in the late 1960s and early 70s. These missions returned with over 380 kilograms of lunar rock and soil, none of which appeared to contain water. Scientists concluded that the moon was bone dry, incapable of supporting life or future human settlement. But science is rarely static. As new technologies emerged in nations beyond the United States joined the race to explore space, that seemingly simple conclusion, that the moon is dry, began to unravel. What followed was one of the most fascinating scientific detective stories of our time, the search for water on the moon. A dry world? Think again. The first clues came not from the moon's surface, but from orbit. In the 1990s, NASA's Clementine and Lunar Prospector missions began detecting unusual signals at the moon's poles. These signals hinted at the presence of hydrogen, an essential component of water. The data weren't conclusive, but they raised eyebrows. Could water, frozen, hidden, ancient, actually exist in the moon's most inhospitable regions? The real breakthrough came in 2008, when India's Chandrayaan-1 orbiter deployed a US-built instrument called the Moon Mineralogy Mapper, M3. This device detected the spectral fingerprints of hydroxyl, OH, and water, H2O, molecules in the top layers of lunar soil. But more astonishingly, it revealed that these molecules were widespread across the moon's surface, not just confined to the poles. Some areas even appeared to have higher concentrations at sunrise and sunset, suggesting a dynamic interaction with solar radiation. Then, in 2009, NASA's LaCrosse mission crash-landed a spent rocket stage into a permanently shadowed crater near the moon's south pole. Following close behind, a spacecraft recorded the plume of debris thrown up by the impact. What it found shocked scientists: clear signs of water ice, along with other volatiles like ammonia and methane, buried just below the surface. Suddenly, the moon didn't seem so dry after all. Where is the water? The moon doesn't have rivers or lakes. Its water exists in less obvious forms, frozen in shadowy craters, chemically bound in minerals, and clinging to tiny grains of dust. The most promising reservoirs are located at the lunar poles, especially the South Pole. These areas contain permanently shadowed regions, PSRs, where sunlight hasn't reached for billions of years. Because the moon's axis tilts only slightly, some crater floors near the poles remain in eternal darkness, creating some of the coldest environments in the solar system, as low as -250 degrees Celsius. In these deep freezes, water can remain stable indefinitely. Estimates suggest that hundreds of millions of tons of ice may be hidden in these polar craters. This isn't just a curiosity, it's a potential game-changer for the future of space exploration. Why lunar water matters. Water is more than just something to drink. It is the foundation of human survival and a key to expanding civilization beyond Earth. On the moon, water can be split into hydrogen and oxygen, the building blocks of rocket fuel. That means future astronauts could launch missions from the moon, rather than from Earth, saving enormous amounts of energy and cost. Moreover, having access to water on the moon would eliminate the need to bring large quantities from Earth. It would make lunar habitats more sustainable, allowing humans to stay longer and build permanent research stations, colonies, or even industries. Lunar water could support crops, drinking supplies, and breathable air. It is not an exaggeration to say that water is the single most valuable resource for turning the moon into humanity's first true outpost in space. The Artemis Era, a return with purpose. NASA's Artemis program, named after the twin sister of Apollo in Greek mythology, is leading the charge to return humans to the moon, but this time, with permanence in mind. Artemis I has already tested the deep space capabilities of the new Orion spacecraft. Artemis II will send astronauts around the moon, and Artemis 3 will attempt a crewed landing near the lunar South Pole, the very region where water ice is believed to lie. The goal is not just to plant another flag, but to establish the infrastructure for long-term exploration. NASA plans to test technologies for harvesting water ice, converting it into oxygen and fuel, and living off the land, an approach known as in situ resource utilization, ISRU. Partner nations like Japan, Canada, and members of the European Space Agency are contributing hardware, robots, and expertise. Meanwhile, private companies like SpaceX and Blue Origin are developing landers and cargo systems to support a permanent lunar presence. Challenges ahead. Finding water is one thing, using it is another. Lunar ice may be buried under meters of regolith, the moon's dusty soil, mixed with rock and debris, or locked in tiny grains. Extracting it will require specialized drills, heaters, and filtration systems that can operate in extreme cold and vacuum. Energy, too, is a problem. Solar power is limited in shadowed regions, and nuclear sources may be needed. There are also questions of planetary protection and ethics. Should we mine the moon's pristine resources? What legal frameworks exist to prevent exploitation or conflict? The 1967 Outer Space Treaty states that no nation can claim ownership of the moon, but commercial use is a growing frontier of legal and diplomatic debate. A gateway to the stars. Ultimately, water on the moon is more than a scientific discovery, it's a stepping stone to the stars. A moon base that can sustain life and manufacture fuel would serve as a launchpad to Mars and beyond. It would reduce dependence on Earth, opening the door to interplanetary travel and the dream of becoming a spacefaring civilization. The moon, once thought to be lifeless and static, is proving to be a dynamic, resource-rich world. The discovery of water ice is turning it into humanity's next great frontier, not just a target of exploration, but a foundation for expansion. As we prepare to return, not just to visit, but to stay, the moon may yet reveal more of its secrets. Beneath its ancient dust lies not just history, but the future.